Greetings to everyone out here. And today I'm going to talk about one of the most interesting topics in the market right now, which is all around economic security and economic risks, with EigenLayer coming into the narrative to build the crypto economic security layer of Ethereum. This has been one of the hottest topics. But what's going on at Chain Risk? So at Chain Risk, we're trying to prevent DeFi's biggest economic exploits, whether it be the DeFi which we've seen in the past and or the DeFi which is right now getting built on top of LRTs, all the money markets which are getting built on top of LRTs, right? So who are we? So we are a passionate team of researchers who have experience in some of the topmost companies in the world, starting from Deutsche Bank, NASA, Walmart, and some of the top colleges of the world. But on top of it, we've been really working hard with some of the protocols right here. So we are already working with Compound on their economic risk management. But on top of that, right now as I speak, we are also launching our Morpho Vaults for Angle. Angle is a stablecoin protocol, so we are launching their Morpho Vaults and along with a collaboration on Renzo. So pretty much what we are going to talk about right now here is recently we released a paper. This paper is about the economic security of MakerDAO. So anyone here who will be willing to read this can just scan this QR code and just go down to the paper and scroll as I speak. But what is this all about, right? So if we speak how we actually visualize the entire DeFi industry to be, then it's more so ever just like a game which is happening amongst the governance, the users, and the protocol parameters which have been set in place, right? So I'll be talking about something called multi-agent influence diagrams, which had been introduced by two of the very famous mathematical researchers called Kohler and Milch, which is now being very deeply worked on by the Google DeepMind team as well. So why even multi-agent influence diagrams, right? So there's an open research statement, research problem statement right now on Ethereum, which says about the formal verification of the game theoretic mechanisms which are there in DeFi protocols. It's an open research problem which has yet not been solved. The second is, you really have a lot of incentive mechanisms in these DeFi protocols. How do you optimize those incentive mechanisms so that any agent which is interacting with the DeFi protocol, agent means users or any liquidators or any arbitrageurs, how are they playing even an equal game, which means a rational and an honest game throughout whatever transactions they make? And the third is, how are we able to get or conquer a Nash equilibrium for each and every DeFi protocol, which means an optimal strategy and an optimal set of parameters for the protocol, so the protocol is stable in all market conditions. So what WTF are multi-agent influence diagrams? This is a very heavy topic to even get a conversation into, but multi-agent influence diagrams can be directly related to agents. So in DeFi, in all of the economic risk management stuff we do, we do something called agent-based simulations. So all of the interactions which are happening with a protocol can be broadly classified into three agents: liquidators, arbitrageurs, and or borrowers and lenders, right? So all of these agents are interacting within a protocol, and all of the different interactions can be classified as different nodes in a graph. Now there are three types of nodes which are possible. The number one is chance variable, right? So what's the possibility or what's the probability of a particular event happening? Let's say, if let's say today rain occurred, then what's the possibility that we could get a crowd here in ETH Dubai? Then the possibility of rain, let's say 5% or even a 95%, we've seen all of that in Dubai this time. What's the possibility of that? That's something which is called a chance variable, which is sort of an external environmental thing which is affecting you. The second is all about decision variables, right? So how are you actually quantifying the decisions which you take? So your decision to come to here, in this case of a rain, is a decision variable which is directly getting impacted by the probability of the chance variable. And the third is utility variable. What was my mindset when I was trying to come here? That's to deliver the speech to you guys and introduce you to the concept of multi-agent influence diagrams. So I want to deliver my speech in the best way possible, right? So the utility in case of DeFi could be to maximize your strategy, maximize your yield inputs or maximize your yield outputs, right? So pretty much that's what the 3 variables of multi-agent inference diagrams looks like. I'll share this deck with all of you guys. I'll have a conversation with Patrick after this to share so that you guys can dive into the major mathematics part of it. But let's deep dive into the multi-agent inference diagrams with an example, right? So what does a multi-agent inference diagrams looks like? So let's say there's a girl called Alice who wants to build her own patio in front of her garden, but then there's this guy Mark who just stays next door. He has let's say a big tree in front of his house which is blocking the view of the patio with a very beautiful beach which is outside. So what can Alice do, right? So Alice doesn't care about the world. She's an absolute Gen Z. She just goes ahead and says that, hey, I'll just poison the tree which is there. And to poison the tree, there'll be an effort which I need to do. Then the tree might get sick, and finally the tree might die, right? But then, Max thinks that if my tree is dying, so Max cannot see that the tree has been poisoned, but he can see that the tree is dying, right? So he can directly call a tree doctor. To call a tree doctor, there'll be a cost which he needs to incur. That will again directly affect whether the tree dies or not, or whether the tree lives or not. And finally, all of this will affect Alice's view from the patio, right? So if you see the graph over here, so it is clearly showing that poisoning the tree through the dotted line is directly affecting the patio. Max might call a tree doctor. He can cure the tree. That will come at some cost. To poison the tree and to monitor it, Alice would always need to sort of do an effort and check whether the tree is dying or not, right? So within this, if you see, so which one is the chance variable, which one is the decision variable, and which one is the utility variable, right? So the decision variable are the top 3 things in squares, which is telling about the poisoning of a tree, calling a tree doctor, or building a patio. These are decisions which you want to do. What's the utility variable? The utility variable are the things which you are incurring. So what's the cost of it? You want to minimize the cost, of course. You want to minimize your effort. And finally, you want to build the view. So the view also comes in as one of the utility variables. You want to maximize the view, right? And finally, what's the sort of chance variables in this? The biggest chance variable is, of course, the tree getting sick, and finally the tree getting died, right? So what's the probability of that? So that's basically shown in ovals. So how are we building multi-agent inference diagrams for MakerDAO, right? So if we see the Maker protocol, then there are a lot of governance and user activities going on. So let's say we quantify all the governance DAO as a set of agents, set of agents from G1 to, let's say, GN, and similarly the users of the protocol, let's say UP1 to PN. And then how are we building up the model, right? So let's look at it very closely. So it's a very interesting thing to look into. Number one is, what are the chance variables? Market conditions, collateral dynamics, demand for DAI, and the security risks. Security risks are inherently coming down from the smart contracts. All of the rest of the 3 are basically market conditions which are coming here. All of these are finally affecting your decision variables. Decision variables over here would be risk parameters which the governance in the DAO decides, which pretty much means which directly affects the amount of debt the user can borrow as well, which is also coming down as one of the decision variables. And using all of this, we are trying to get 2 utilities and maximize 2 utilities. Number one is the profitability, and the second is the sustainability of the protocol. All of this will come at a risk and reward ratio. So you have to, so this is basically a trade-off, right? So whenever you want to increase the top lines, there'll be an increase in the risk, and then you need to also sort of manage the risk at the same time so that you don't get hacked and all of that. So this is basically how the made looks like in case of MakerDAO. You guys can go through a research paper to look into the depths of the modules and details. But that's pretty much it. What the problem does MADE solve for MakerDAO, right? So we're coming up with a next paper in ETH Belgrade, which clearly gives you the outputs of it. So what are we doing over here? Number one is calculating the utility, right? So there were 2 utilities. One is the profitability, and the second one was sustainability. How do you maximize both of these using strategies? So how can we find the optimal strategy sigma so that at any given point of time, my protocol is maximum sustainable and at the same time maximum profitable? And secondly is to evaluate the Nash equilibrium. Now, what do we mean by Nash equilibrium? It just says that a strategy profile is a Nash equilibrium if no agent has the incentive to deviate from the strategy specified from the profile by him, as long as the other agents do not deviate from the specified strategies, right? Which means that all of the players in the ecosystem, all of the agents are playing evenly. They do not have any added incentives, and all of them are not only rational, but they're all honest, which means that nobody has a gain over somebody else. And if they have it already rationally, which is the game of the entire DeFi space, that somebody makes money, somebody loses it, right? So that's pretty much what we are doing for MakerDAO. Happy to take up some questions on this. Don't let your risk program take a setback. You can quickly scan our Twitter. You can quickly go to my Twitter as well. I usually post a lot of research content on this. So yeah, happy to take up any questions if there. Yeah. Yeah. So there are basically three forms of agents here. One is, of course, the liquidator. The second is the arbitrager, and the third is the borrower. So we are modeling them, especially using all of the mainnet data, which is present below, and we're using reinforcement learning models to model all of these, and then finally run all of these simulations in our platform, where we have built a huge scalable platform on top of Revum, where we are running Monte Carlo simulations at scale, so as to give you the confidence intervals and converge that Monte Carlo simulations to the different set of parameter values, so that you're able to finally get into the Nash equilibrium. Fine. Cool. Any other questions? Or I think we are already on time. We'll wrap it up. Cool then. Pretty much excited to have a conversation with you guys outside.